Find the LCD for each of the following sets of two fractions. Rewrite each fraction with the LCD. Alright, exercise A, we have 7 over a plus 2 by a minus 5, and we have a minus 6 over a minus 5 by a plus 3. So notice that our denominators are already factored, so to find the LCD, we simply need to list the factors, the distinct factors. So I have an a plus 2, I need an a minus 5, and I need an a plus 3. And remember, we only list them to the highest power, and the a minus 5 is only being raised to the first power in each of those denominators, so I've only listed it to the first power. Alright, so now we say to ourselves, in a sense, what's missing in each of those denominators. Alright, in the first denominator, I have the a plus 2 and the a minus 5. I need the a plus 3. So I multiplied by a plus 3 in the denominator. I multiply by a plus 3 in the numerator. In the second fraction, I say to myself, what's missing? I have the a minus 5 and the a plus 3. I need the a plus 2. I multiply by a plus 2, and I need to multiply that entire a plus 6 by a plus 2. Alright, so now we can rewrite these fractions. The first fraction is applying the distributive property, 7a plus 21, and I'll write the denominator as a plus 2, a minus 5, a plus 3. Alright, so don't multiply out the denominator. Leave it as is. Alright, my second fraction, I have a minus 6 by a plus 2. So here you'll need to use the FOIL technique, or just your general multiplying polynomials idea. And that would yield a squared minus 4a minus 12. And again, the denominator, I'll write as a plus 2 by a minus 5 by a plus 3. Exercise B, I have x plus 4 over x squared minus 3x minus 18, and I have 5x over x squared minus 5x minus 6. Alright, so the first thing I'm going to do is I'm going to write the factored forms of those denominators. X squared minus 3x minus 18 factors as x plus 3 by x minus 6. And my second denominator, x squared minus 5x minus 6, factors as x plus 6, x minus 6 by x plus 1. So, looking at those denominators, my LCD is x plus 3 by x minus 6 by x plus 1. Alright, so comparing to the first fraction, the first denominator in its factored form, the first fraction's denominator is missing the x plus 1. So I'm going to multiply by x plus 1 in the denominator and by x plus 1 in the numerator. Again, comparing to the factored form for the second denominator, it is missing a factor of x plus 3. So I'll multiply both numerator and denominator by x plus 3. Alright, so my fractions are equivalently the first fraction using FOIL, or general multiplication of polynomials, is x squared plus 5x plus 4 over the common denominator, and I'll just use the form that I have written underneath, x plus 3, x minus 6, x plus 1. And my second fraction, applying the distributive property in the numerator, 5x squared plus 15x, and the common denominator, x plus 3 by x minus 6 by x plus 1.